Hi, hello everyone. I am Ashanna, Director of Sadhana, Navodaya and Sainik Coaching Center from Peddapelli. Now I would like to tell you topic 3, factors and multiples. In this video, I am going to teach you divisibility rules or tests of divisibility. Divisibility rules are tests of divisibility. In this divisibility rules, what we have to learn by 10, 5, 2, 3, 6, 9, 4, 8, 11. Let us learn one by one. First, divisibility rules. What is the divisibility rule? Or tests of divisibility. The process of checking whether a number is exactly divisible by given number or not without actual division is called a divisibility rule or tests of divisibility rule. Once again, the process of checking whether a number is exactly divisible by a given number or not without actual division is called a divisibility rule. Another name for divisibility rule is tests of divisibility. Are you perfect in this topic? If yes, I am giving a challenging question here. The question is 987 crore 65 lakh 43,120 is divisible by 10, 5, 2, 3, 6, 9, 4, 8, 11 or not. If you have perfect, you pause this video and solve the question. I will tell you answers after finishing this topic. First one, divisibility by 10. What is the divisibility rule of 10? If a number has 0 in ones place, then the number is exactly divisible by 10. To understand this, let us take an example. 1, 2, 3, 0. So in this we have in ones place ones, so tens, hundreds, thousands. We have to check ones or units place. If it is 0, that is divisible by 10. One more example. 9870 1 2 3 4 5 6 7 8 9 0. So these all are exactly divisible by 10. Next 1 2 3 5. Is this divisible by 10? No. This is not divisible by 10. Is this divisible by 10? No. This is not divisible by 10. So these all are exactly. Divisible means exactly. No remainder. Without remainder. Next, second one. Divisible by 5. What is the divisibility rule of 5? If a number has 0 or 5, in ones place, then the number is exactly divisible by 5. Let us see to understand this rule. 1 to 5. So here we have 5 in units place or ones place. 9, 6, 0. Here we have 0 in ones place. 0 in ones place or units place. 9,875. So here we have 5 in units place. So these all are exactly divisible by 5. I am giving some more examples. Give answers. Are these divisible or not? 5432 543 55,553 is this divisible by 5? 5555 55,55,551 are these divisible by 5? No, these aren't exactly divisible by 5. In ones place here we have 3, in ones place here we have 3, in ones place here we have 1. So that's why these are not exactly divisible by 5. These are not exactly divisible by 5. Next 3, divisible by 2. What is the divisible rule of 2? If a number has 0 to 468 in ones place, then the number is exactly divisible by 2. Once again, if a number has 0 or 2 or 4 or 6 or 8 in ones place, then the number is exactly divisible by 2. Or in other words, all even numbers are exactly divisible by 2. To understand this concept, to understand this rule, I am writing here some numbers. Tell me which are exactly divisible by 2. You only tell me. 1230, 3,521, 1,234, 52, 76, 878, 1,289. So which are exact divisible by 2? Tell me. Is first one, second one, third one, fourth one, fifth, sixth, seventh. So in first number 1230, here we have 0 in ones place 0. So this is divisible by 2. Here we have 1 in ones place. So this is not divisible by 2. Here we have 4. So this is divisible by 2. Here we have 2 in ones place. So divisible by 2. Here we have 6. So divisible by 2. Exact divisible by 2. Here we have 8. So it is divisible by 2. Here we have 9. So it is not divisible by 2. So are your answers are correct? Yes, I know you are correct. So which digits have in ones place the numbers exact divisible by 2? 0, 0 or 2 or 4 or 6 or 8. If a number has 0, 2, 4, 6, 8, any one of the digit, if a number has any one of the digit 0, 2, 4, 6, 8 in ones place, then the number is exactly divisible by 2. Next, fourth one, divisibility by 3. What is the divisibility rule of 3? If the sum of all the digits of a number is exactly divisible by 3, then the number is exactly divisible by 3. Once again, if the sum of all the digits of a number is exactly divisible by 3, then the number is exactly divisible by 3. To understand this, we have to observe few examples here. Sum of the digits. How much here? 1 plus 1 plus 1. Here we have getting 3. Sum of the digits is 3. So this is exactly divisible by 3. This means what? 111. There is a doubt, we can actual division here. 3 3s are 9. 2 3 7s are 21. So 0. So it divided exactly. No doubt at all. These are the rules. Rule is rule for all, not only few. Rule for all. So is 123 is divisible by 3? We can check. 1 plus 2, 3. 3 plus 3, 6. So sum of the digits 6 is divisible by 3. 3 1s are 3 2s are 6. So it is exactly divisible by 3. So that's why this number 123 also exactly divisible by 3. No doubt at all. Next, here we have 1243. Is this divisible by 3? We can check sum of the digits. 3, 1 plus 2, 3, 3 plus 4, 7, 7 plus 3, 10. Is 10 exactly divisible by 3? No. 10. 3 3s are 9. 1. So here we have 1 as a remainder. So that's why this number also not exactly divisible by 3. If there is a doubt, you may do actual division. 1243. 3 4s are 12. 0, bring down 4. 3 1s are 3. 1, bring down 3. 3 4s are 12. So 1 is the remainder. You may think here is the 3, it is divisible, but not divisible by 3. So this is not divisible by 3. This means 1243 number not exactly divisible by 3. Next, fourth one, 54,321. Is this divisible by 3? We can check this. Check means sum of the digits. 5 plus 4, 9, 12, 14, 15. So 15 is exact divisible by 3. 3 5s are 15. That's why this number also exact divisible by 3. Next, 1333. Is this divisible by 3? You may think it is divisible by 3, but not exact divisible by 3. So we can check. 4, 7, 10. 10 is not exact divisible by 3. That's why this number also not exact divisible by 3. So here we have 1,11,111. Is this divisible by 11? 3. We can check. 2, 3, 4, 5, 6. So 6 is exactly divisible by 3. So that's why this number also exactly divisible by 3. Next, here we have 2,333. Is this divisible by 3? We can check. 5, 8, 11. 11. Is 11 divisible by 3? No. So that's why this total number also not exactly divisible by 3. Not exactly divisible by 3. The divisibility rule of 3. What is the divisibility rule of 3? We have understood. If the sum of all the digits of a number is exactly divisible by 3, then the number is exactly divisible by 3. In sometimes there will be difficult to check the sum if it is divisible by 3 or not. So that's why here we have another rule to check 3. What is the another divisibility rule of 3? The digital root of a number is 3 or 6 or 9 then the number is exact divisible by 3. To understand this, I am giving here one more problem. 6, 5, 4, 3, 2, 1, 0. Is this divisible by 3? We can check. 6 plus 5, 11, 15, 18, 20, 21. So we got 21 is the sum of the digits. So you understood it is divisible by 3. Yes. So after getting this 2-digit number, again we have to add 2 plus 1, 3. So we got here 3 is the digital root. This single digit is called digital root. Digital root. Digital root of this number is 3. If the digital root of a number is 3 or 6 or 9, 3 digital root 3 or 6 or 9, then the number is exactly divisible by 3. What is the digital root? What is the definition of digital root? When we add the digit in a number till we get a single digit, that single digit is called digital root. So one more example to understand this digital root. 777. So what is the digital root of this number? Sum of the digits is 49. 7 7s are 49. Is this 49? Is this 49 digital root? No. Here we have 2 digits. Again we have to add. How much here? 4 plus 9. How much 4 plus 9? 13. Is this digital root? No. Here we got a 2-digit number. So again add. How much here? 4. So this is the digital root. Digital root of this number is how much? 4. Is this divisible by 3? No. Why? Because here we got 4 as digital roots. That's why this number is not exactly divisible by 3. So I have understood the digital root. Yes, I know you understood well. Once again, when we add the digit in a number, till we get a single digit, that single digit is called digital root. When a number is divisible by 3, if the digital root of a number is 3 or 6 or 9, 3 or 6 or 9, then the number is exactly divisible by 3. I am giving here a big number. Is this divisible or not? You solve and ready to give answer. 9876543210. 9876543210. Is this divisible by 3? 9 plus 8, 17, 24, 30, 35, 39, 42, 44, 45. So 45. Is this digital root? No. Here we have 2-digit number. That's why add once again. 4 plus 5, 9. So 9, we got a 9. The digital root of this number is 9. So that's why this big number is also divisible by 3. So big number, what is this big number? We can read 987 crore 65 lakh 43,210. 10. So this is the number. So it is exactly divisible by 3. Next, divisibility by 6. Fifth one, divisibility by 6. If a number is exactly divisible by 2 and 3, then the number is exactly divisible by 6. Once again, if a number is exactly divisible by 2 and 3, then the number is exactly divisible by 6. To understand this rule, we have few examples here. 2 and 3. We have to check 2 and 3. 2. What is the divisibility rule of 2? All even numbers are exactly divisible by 2. Even. Or if a number has 0, 2, 4, 6, 8 in ones place, then the number is exactly divisible by 2. So that's why this is even number. So it has 0 in ones place. So even number. So it is exactly divisible by 2. Next, is this divisible by 3? We have to check. What is the divisibility rule of 3? If the digital root of a number is 3 or 6 or 9, then the number is exactly divisible by 3. Digital root. We have to find digital root. What we have to get to digital root? 3 or 6 or 9. So 3 or 6 or 9. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4. Sorry, here, this first problem. 3 plus 2, 5, 5 plus 1, 6, 6 plus 0, 6. Here we have the digital root 6. So that's why it is exactly divisible by 3. 3210 is exactly divisible by 2 and 3. So that's why this is also exactly divisible by 6. So this is the first problem. Next, second problem. Second example. Is this divisible by 2? Yes, it is a even number, or in ones place there is 4. So it is exactly divisible by 2. Exactly divisible by 2. Next, with 3 we have to check. Is this divisible by 3? We have to count this. We have to find the digital root. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. 10, it is a 2-digit number. Once again add this, 1 plus 0, 1. So here we get 1 is the digital root. So that's why this is not exactly divisible by 3. So that's why it is not exactly divisible by 6. Next, example 3. Is this divisible by 6? To check this, we have to check with 2 and 3. So is this divisible by 2? No, it is not a even number. That's why it is not divisible by 2. So no need of checking this divisibility by 3. So it is 9, 12, 14, 15. We are getting 15. 15 means 6. So this is divisible by 3. But no need of checking this. If a number is not exactly divisible by 2 and 3, must not exactly divisible by any of the numbers 2 or 3, that not exactly divisible by 6. So that's why this is not exactly divisible by 6. Next, fourth problem, fourth example. Here is a big problem. So this is divisible by 2 because it is even number. Is this divisible by 3? We can check. 9 plus 8, 17, 24, 30, 35, 39, 42, 44, 45 plus 0, 45. So digital root not get here single digit, we have 45. Again we have to add 4 plus 5, 9. So the digital root is 9. So that's why we got 9 as digital root. That's why this is exactly divisible by 3. So that's why this 987 crore 65 lakh 43,210 is also exactly divisible by 6.